Good morning, students. Today we start a new topic, that is salt in acid, base, and salt. Salts are the compound which is formed by neutralization reaction between an acid and a base. What are salt? Salts are compound which is formed by neutralization reaction between acid and base. For example, NaCl. It is formed by the reaction of hydrogen chloride plus sodium hydroxide is equal to sodium chloride and water. That is known as salt. When crystallized from aqueous solution, the salt hydrates. When heated, these salt lose their crystalline water, become anhydrous. They lose their water is known as anhydrous. Many salt crystallizes as hydrates. For example, copper sulfate into 5H2, pentahydrate, cobalt chloride, hexahydrate, stainless chloride dihydrate. The number of water molecule attached to the crystal of a substance are called water of hydration. Water of hydration. Hydrate is the salt containing specific number of water molecule as part of solid crystalline structure. As part of solid crystalline structure. Hydrate is the salt containing specific number of water molecule as a part of solid crystalline structure. Water of hydration is the water retained as a part of solid crystalline. Water of hydration is water retained as a part of solid crystalline structure of some salts. So here are the some salts. Salts, as I have tell you, that they may be neutral, acidic, or basic. Salt may be neutral, acidic, or basic. If the parent acid is strong and parent base is strong, then the salt become neutral. For example, NaCl. If the parent acid is strong and base is weak, then the salt become acidic, or parent base is strong and parent acid is weak, then it becomes a basic. Salts of H2SO4 are called sulfates. Salt of hydrogen chloride are chloride, and salt of nitric acid are called nitrates. Salts of nitric acid are called nitrates. There are the three different types of the salts are here. Salts of, for example, parent acid as hydrogen fluoride. Hydrogen fluoride is, as I think, is a strong or weak. Parent base sodium hydroxide. So you can say hydrogen fluoride is a weak acid and sodium hydroxide is a strong base. So NaF is a basic salt. Sodium fluoride is formed as basic salt. Parent acid HNO3 nitric acid is a strong acid, and parent base ferric hydroxide. Here it is the ferric hydroxide. Strong or weak, it is a weak. So it forms the ferric nitrate, is acidic salt. Parent acid HCl, which is strong, and parent base sodium hydroxide, which is strong base. Parent, which is strong base. So HCl and so NaCl is a neutral salt. NaCl is a neutral salt. NaCl becomes neutral salt. Here the different types of the salt are shown on the basis of their acidity and basic or the neutral. Three types of the salts are formed. Chemicals from common salt. As first we have formed the sodium chloride. So which chemicals are formed from sodium chloride? Sodium chloride is known as common salt. Important component of our food. Its main source is seawater. Its main source is seawater. It also exists in the form of rocks, and sodium chloride obtained from rocks is called rock salt. Used for preparing sodium hydroxide, baking soda, washing soda, sodium bicarbonate, and sodium carbonate. So first salt is the sodium hydroxide or caustic soda. Sodium hydroxide or caustic soda. Sodium hydroxide is prepared by passing electricity through an aqueous solution of NaCl. NaCl के aqueous solution में हम इलेक्ट्रिसिटी पास करते हैं, तो उससे हम क्या बनाएंगे? कास्टिक सोडा. NaCl in water is also known as brine. brine. Brine is a word which is used for NaCl in water. Aqueous solution of NaCl is known as brine. NaCl plus water forms sodium hydroxide plus chlorine plus hydrogen. Here it is also called a chlor-alkali process because the product formed are alkali and chlorine. Product formed in this reaction of sodium chloride and water are sodium hydroxide, that is alkali, and chlorine. So process is known as chlor-alkali process due to the formation of chlorine and sodium hydroxide and alkali as a product. Properties: it is a white translucent solid. You know very well it is white translucent. It is readily soluble in water to give a strongly alkaline solution. Crystals of sodium hydroxide are deliquescent, hygroscopic, absorb water. अगर आप इसे बाहर रख देंगे मॉइस्चर में तो ये क्या कर लेगा, वाटर एब्जॉर्ब कर लेगा, डेलिक्विसेंट होता है. क्रिस्टल्स ऑफ सोडियम हाइड्रोक्साइड आर डेलिक्विसेंट, that is they absorb water. After that, next is the bleaching powder, calcium oxychloride. Bleaching powder is calcium oxychloride. In all these salts, you must know their properties, usage, process of formation. There are the 5 salts. Bleaching powder, calcium oxychloride, prepared by passing chlorine gas through select line. What is select line? Calcium hydroxide is select line and calcium oxide is line. That is the calcium hydroxide plus chlorine form the bleaching powder, calcium oxychloride plus H2O. For bleaching cotton and linen in textile industry, these are the uses of the bleaching powder. For bleaching cotton and linen in textile industry, for bleaching wood pulp in paper industry, for disinfecting drinking water. ड्रिंकिंग वाटर को और आजकल सैनिटाइजेशन में जो यूज हो रहा है वो ब्लीचिंग पाउडर होता है जो घरों में सैनिटाइज करके जाते हैं. वॉशिंग सोडा, सोडियम कार्बोनेट इनटू 10H2O और डेकाहाइड्रेट, सोडियम कार्बोनेट डेकाहाइड्रेट obtained by heating the baking soda in turn is obtained by passing carbon dioxide gas through the sodium chloride solution saturated with ammonia. Sodium chloride, water, carbon dioxide and ammonia. It forms ammonium chloride and sodium bicarbonate. Sodium bicarbonate then form the sodium carbonate plus water and carbon dioxide, sodium bicarbonate into sodium carbonate. Recrystallization of the sodium carbonate give the washing soda. जब इसका रिक्रिस्टलाइजेशन करते हैं वाटर में डिजोल्व करके तो इसके अंदर सोडियम कार्बोनेट इनटू डेकाहाइड्रेट 10 वाटर मॉलिक्यूल अटैच हो जाते हैं, दैट फॉर्म द सोडियम कार्बोनेट और वॉशिंग सोडा. इट इज यूज्ड इन ग्लास, सोप एंड पेपर इंडस्ट्री. इट इज यूज्ड फॉर रिमूविंग परमानेंट हार्डनेस ऑफ वाटर. इट कैन बी यूज्ड एज ए क्लीनिंग एजेंट फॉर डोमेस्टिक पर्पज. इट कैन बी यूज्ड एज ए क्लीनिंग एजेंट फॉर डोमेस्टिक पर्पजेज. Then chemicals from common salt, that is the baking soda, sodium bicarbonate, prepared by passing carbon dioxide gas through the brine solution saturated with sodium chloride, water, carbon dioxide and ammonia. It forms ammonium chloride, sodium bicarbonate. The precipitate is sodium bicarbonate is filtered off. Properties of the baking soda: it is a white crystalline solid springly soluble in water at room temperature. Its aqueous solution is weakly alkaline due to hydrolysis. On heating, it decomposes to give sodium carbonate and carbon dioxide. Sodium bicarbonate, sodium carbonate plus water plus carbonate. It reacts with acid to give carbon dioxide gas. Sodium bicarbonate plus HCl. It gives sodium chloride plus water plus carbon dioxide. It is used as a component of baking powder, baking soda and tartaric acid. It is used on soda acid fire extinguisher. It acts as a mild antiseptic and antacid. It acts as mild antiseptic and antacid. Then another chemicals from common salt are plaster of Paris, calcium sulfate hemihydrate. Calcium sulfate hemihydrate. Its chemical name is calcium sulfate hemihydrate. It is obtained by heating gypsum up to 373 Kelvin. Calcium sulfate dihydrate, it forms the calcium sulfate hemihydrate plus water. Gypsum plaster of Paris on treatment with water, it's again converted into gypsum and sets as a hard mass. calcium sulfate, hemihydrate plus water. It forms calcium sulfate into water. Plaster of Paris gypsum. It is used by doctor for setting fractured bone. It is used for making statue, models, and other decorative materials. It is used for making another decorative materials. Then next is the measuring pH. Now that we know that how to calculate pH of a solution, how do we measure it in the lab? First of all, I want to tell you what is pH, power of hydrogen, the concentration of hydrogen ion. There are several ways to test pH. Number one, by indicators, paper and chemicals. Blue litmus paper turns red in acid and blue in base. pH paper multicolor universal indicator like phenolphthalein, methyl orange, methyl red. Natural indicator like red cabbage, reddish turmeric, litmus, logwood, and algerine, China rose. These are the some indicators. pH meter, 7 is the neutral, less than 7 acid, and more than 7 that is the base. More than 7 that is base. Choosing the correct indicator. Not all the indicators shift color at pH 7. Many changes color over a wide range of pH values. When testing a sample for acidity or basicity, it is to choose an indicator that has color change close to pH 7, or use pH paper, use a pH meter to get a digital reading. Some indicator only work in a specific range of pH. Choosing the right one is important. Once the drops are added, the sample is resumed. एक बार अगर हम उसमें किसी भी इंडिकेटर के ड्रॉप डाल देंगे फिर उसे दोबारा टेस्ट नहीं कर सकते. Here the indicators are the substances that will change color when they come in contact with acid or base. इंडिकेटर वो सब्सटेंस होते हैं जो एसिड और बेस के कांटेक्ट में आते ही कलर चेंज करेंगे. Why do we use indicator? Indicators are safe way of the scientist to determine what substance is acid or alkali or base. Indicators are the safe way used by the scientist to determine substance is an acid or alkaline. Most are large molecules that act as weak acid. Most are large molecules that act as weak acid. Color changes occur when the molecule is ionized. Act as acid or unionized, act as base. Universal, the color of the acid may be ionized or unionized. Universal indicator is an indicator which contain a mixture of substances. What are universal indicator? Give its example करके 1 marks question आता है. Universal indicator is an indicator which contain a mixture of substances that are able to give different color corresponding to different pH value. Used to determine the strength of acid and alkali by observing the change in its color. Color depends on the pH. That is, color changes with pH. All indicators are weak base or weak acid. The color of indicator is due to ionic part of the indicator. Table below show colors of universal indicator corresponding to pH scale. Color of universal indicator, if the pH is 0 to 2, then it is red in color. 3 to 4 orange, 4 to 6 yellow, and 7 pale green. 8 to 11 green blue, and 12 to 14 violet. That are of different colors of the acid as well as base. Solution must be colorless. Eye must be able to detect the change. Eye must be able to detect the change. Then the indicators of the litmus test or the paper test. Litmus is an indicator. It changes color in acid and alkaline solution. Litmus is an indicator. It changes color in acid and alkaline solution. Different indicators show different colors. Litmus is red in acid and litmus is blue in alkali. For this, we have to, how we can check the litmus test. Put a stirring rod into the solution and stir it. After that, put a litmus. It will give red color in acid and blue color in base. Take the stirring rod out of the place. A drop of the solution from the end of the stirring rod onto a piece of the paper. Read and record the color change. Note what the color are the indicators. What are the indicators? pH paper. pH paper is also used pH paper, you can see the behavior of the salt in water. Salt solution, sodium chloride, potassium bromide, barium nitrate. pH is 7.0. Nature of ion, cation of strong base, anion strong acid. Ion that react with water, these ions do not react with water. Acidic, ammonium chloride, ammonium nitrate, less than pH 7, contains weak base and anion of strong acid. These contain the cation. Acidic aluminum nitrate, chromium chloride, ferric bromide, small or highly charged cation. Anion of the strong acid is cation. Then basic, sodium acetate, potassium chloride, sodium carbonate, cation of strong base and anion of the weak acid, so it forms the anion. There are the different colors are shown in the diagram also. These are the different colors shown in universal indicator, changes color in acid as well as in alkali. Here the colors of acid and alkalis are shown. As I am telling you already, in acid they show the color of red, orange or mild yellow, and in base 7 is the neutral, that is like about to be green, and after that the violet is the strong basic. And for different indicator they have shown the bromomethyl blue, litmus, methyl orange and phenolphthalein. Methyl orange and phenolphthalein are the colors of different, are shown here. These are the universal indicators. You can see this table also. Using small samples of two types of indicator, find out to be flowing are acidic, basic or neutral. Sulfuric acid, universal indicator red, litmus red, acid. Water is green, red, blue, neutral. HCl, HNO3 are red, and sodium hydroxide and ammonium hydroxide are blue, so these are base. These are the some indicators or the colors are shown here. Then you can see it. These are the some changes which can you see it.